What is up? This is Alan with Undesired Sanity, and I just wanted to make a quick video about the Dark Hero motherboard from Asus. If you haven't heard of the new Asus Republic of Gamers Crosshair VIII Dark Hero motherboard and why it's in demand and sold out everywhere, I'm about to show you. This is the only motherboard that supports the dynamic OC switching. What that means is you can still have a manual overclock in all core performance, and then also take advantage of the boost clocks that AMD has put into the chip for single core or in light load operations. So if you're familiar with overclocking Ryzen processors in the past, like the 3000 series, you'll know that you can't have both. You can either manually overclock, and it'll be a static clock throughout all cores all the time, which is great. And depending on what you get, but then you lose the auto boost or auto clocking, overclocking capabilities that the Ryzen processors have built in. So what Asus has done with this motherboard only to date is to have both best of both worlds, and I'm about to show you how we're able to do this with the Asus ROG Crosshair VIII Dark Hero motherboard. This build is the instant build turkey build that I've been building for my friend. He has dumped a lot of money into this build. It's a $5,000 plus PC. We have a Ryzen 9 5950X with the Dark Hero motherboard, a Gigabyte Vision OC RTX 3090, 32 gigabytes of 36 megahertz CL16 1636 in quad channel, 4x8 sticks, within a Coolmaster H500M with an EVGA 1000 watt power supply. The CPU cooler is the NZXT Kraken Z73 360 millimeter radiator. It's a awesome cooler. It looks great. The LCD screen is just one of the best features of this AIO. And again, we went with a big Z73 because he has the Cooler Master H500M, and we have a top mount done the right way. So let's go into the BIOS and settings here. So for this particular build, I spent a few hours over the past couple days tweaking this build for my friend. It's one of the services I provide. I'm getting the most performance out of the machine that I'm building. And so let's start off with the memory. I've set the AI overclock tuner to manual. I'm overclocking his memory to 38 megahertz. And this has just been completely stable throughout all the bench testing and games I've played with this machine so far. F-clock is at 1900 megahertz. DRAM timings, I just set it at the memory's defaults was 16, 16, 16, 16, 36. And then the voltage I'm running is a manual voltage of 1.4 volts on the memory. Now, so if you're familiar with Ryzen and taking advantage of their precision boost overdrive, it's just as simple as going into the setting and enabling it here. I've also enabled the PBO F Max enhancer just to get a little bit more of a peak boost and maybe hold that boost a little bit higher. So these are the only two settings I've done in the PBO. I have in other systems gone into detail of manually setting these. For example, setting the PPT limit, TDC limit, EDC limit. These are my previous settings that I was experimenting with. I didn't see much improvement. Scaler also set it to manual to 4x, and then max CPU boost override it to 200 megahertz. But yeah, I think after several hours of bench testing, just a default enabled work was giving us the best performance on this particular build here, with the memory and the cooler and everything else that we can pull from the VRAM. Sorry, the MOSFETs from the Dark Hero motherboard. Anyway, so how do we go and enable manual overclock? I've already spent the hours on manually overclocking this system safely, using Prime 95 and Cinebench. I'll just use Cinebench as a demo going into this video later on. But the sweet spot I found is 4.65 gigahertz across all 16 cores. So that's a lot of clock for 16 cores and a lot of heat. But it's we have this Kraken Z73 AIO to take care of everything that we needed. So how do we enable the dynamic switching between manual overclocking and retain that boost auto boost feature from Ryzen? So we go into CPU core ratio per CCX. So we have the 5950X and 5900 has multiple CCXs within the chip itself. If you want to know what those are, the 5000 series is a multi-chip chipset CPU, and so they have different CCXs. So what I've done is there's two CCXs within the 5950X and the 5900. I've also done this on my own personal machine, which is a 5900X and EVGA RTX 3090 FW3 Ultra. But I've set the core voltage that I wanted. It was 1.3 volts. So I know this isn't going to be too damaging to the chip, and even though some people may say it's a little high, but it's worked fine during my bench testing and overclocking. So I set both CCX ratios to 4.65. It seems to do well on both banks, and they've been individually testing those. So then we go down here to dynamic overclock switcher. So once you enable this, it'll open the rest of the menu here, and what we need to do here is set the threshold of when to switch to manual overclock mode. This value here is in amps, so anytime a workload that is needed with all cores that will draw more than 45 amps total on the chip, it will switch to manual overclock mode. So we set 45 amps. I've seen other videos about this, and I kind of tested this myself. 45 amps is the kind of sweet spot where you really need the power of all cores to do the work, whether it's video rendering, video editing, H.264 slow encoding for like something like OBS or something else. So we set 45 amps as the threshold to switch over to manual overclock mode. We just let the rest set to auto, which is the calibrated temperature of when to switch back. We'll let AMD decide when to do that itself. So yeah, let's go ahead and boot this machine up. While we're waiting, so again, this has been a beautiful build. I've been very happy to get a chance to build this for my friend here. This, I would consider this a premium build. This machine is just absolutely phenomenal. My personal machine is a 5900X. It's also a phenomenal build, but I'm kind of jealous of the extra 4 cores that this beast has when it comes to, because I also do edit my own videos on the same machine that I game on. So let's go ahead and boot into Windows. The Kraken Z63 is great. The only thing I don't like about it is that it's USB controlled. So every time you boot up, you have to wait for it to enumerate on the USB bus in order to start communicating with it and get accurate readings on either the display or loading your GIF and color scheme. So that's what this display model here is. This overlay is from the NZXT Kraken Z73. Let me go ahead and launch hardware info. And what I have here is I've already kind of filtered out what I wanted to monitor: the voltage, the clock speed, and down here is the temperature. So let's test out that manual overclock mode of 4.65 gigahertz. As you can see here, right, all the cores are kind of doing their own thing. They're not clocking yet. A static clock like a manual overclock would. So Let's go ahead and launch Cinebench. All right. Let's launch Cinebench here, and then we'll start the multi-core test here. What you should see when I start that test is all 16 cores jump to the manual overclock 4.65 gigahertz. So here we go. It jumped to 4.7, 4.69, 65. So it's roughly close here. We're holding at 72 degrees. I do have the AIO set to performance, so it'll catch any of the upswing of peaks. Look at that, beautiful, all 16 core manual overclock on this machine. So we should hit a score of, yep, around 30,000 points, just above 30,000 points, which is pretty good for this machine. And a manual overclock of 4.65. I didn't want to go any higher because of the temperatures in the environment. If it was staying in my house, I probably would have cranked it up a little bit more, maybe 4.7. But again, there's always risk to that. So again, we saw the manual overclock take place. Now, if we go back and let me just reset this counter here. We go into single core testing. We'll see the auto boost, the peaks of Ryzen's hitting those single core boost clocks. Here we go. We got 4.9, 4.7, 4.8. Pretty soon here we should see some 5 gigahertz spikes here. But then again, the rest of the cores are kind of sitting in idle. And this is what your gaming does. Your gaming does not use all 16 cores or all the cores. It's going to use only a couple of the cores and make use of that single core performance boost, right? So 4.9, again, we're cranking along here. We should see some 5s here, hopefully. I mean, I saw some 5s last night and the night before, but I guess it just all depends on the conditions, right? I mean, we're at 61 degrees C here. If we were dipping down maybe into the 50s, we could see some 5 gigahertz. But this is what the Dark Hero motherboard is capable of, and why it's in such demand by everybody using a. I only really recommend it for the 5000 series with a higher core count. I mean, you could run this on a 5600 or a 5800X, but if you're going to be doing any type of high load for video rendering, you're probably looking at a 5900X or a 5950X here. So that's it for now. I just wanted to kind of point out why the Dark Hero motherboard. It is actually a great motherboard in general. It's an X570 chipset. It does not have a VRM fan, which is great. By doing so, it just uses large sinks to cool the motherboard compared to other X570 boards. That's another feature of it. And again, the BIOS. If Asus launches this BIOS on other motherboards, that would be sick. But right now, this is the only motherboard to date with this dynamic OC switching here. And that should be it. There we go. We hit 5 gigahertz here. All right. Thanks for watching, and till next time.